Hi, I'm Larry Garfield, and welcome to Cooking with Crell. Let's suppose for a moment that you're having a dinner party. You're having some friends over, and you want to make dinner. Of course, you start with the most important part, dessert. So you try and decide, I want something sweet that can be eaten with the hands. Okay, so I could try sugar, and okay, what do I have to hold the sugar together? Maybe flour and water? Maybe? Or butter might work, but butter melts. So how am I going to bake this? How long am I going to bake it for? So you could take a day or two and experiment with this and get a lot of runny mess before you come up with something edible. Or you could do what any smart person these days does and go online. And you find, hey, look, a recipe for something called cookies. This sounds good. And it takes butter, white sugar, brown sugar, eggs, flour, baking soda, interesting, vanilla, I wouldn't have thought of that. Ooh, and chocolate chips. I like chocolate chips. And this only takes 20 minutes to make. Awesome. So in about a half hour, you've now made dessert. And you can now spend your time working on the rest of the meal. In cooking, this concept is called a recipe. In software design, it's called a design pattern. Design patterns are just recipes for common solutions to common problems. As an example, let's suppose you have a task you need to perform in your program, and it's kind of complex to set up, but you want to allow other parts of the code to modify it. Okay, you could try and come up with something that fits that solution, or you could look up a common design pattern called command. In the command pattern, you have some object that represents the task you are about to do. And then you can call methods on it, pass things into the constructor, and so forth to prepare that object, to set up what it's going to do later. And then you can pass that object around to other parts of the system. Other parts of the system can call methods on it to change what's going to be done. And finally, you call an execute method on that object. And that will go do whatever it's going to do. Great. But you also get a lot of extra benefits with this approach that you may not have thought of. For example, this command object, you don't need to run immediately. You can serialize it to the database and run it a few days later, or through a queue. Or since the object itself, you know, has exactly what it needs to do configured in it, the command pattern allows you to also have an undo command. Because just as you know everything you need to do to go forward, that means you can easily derive, in many cases, everything you need to do to go backward. Great. Just by looking up that information, we've got more capability and more flexibility than we expected. Wonderful. Another common pattern, let's say you have an object that is really complicated to set up. It takes a lot of work, it takes a lot of boilerplate code. Or maybe you don't even know what object it's going to be, because it could be from one class or another class, depending on user configuration, depending on the situation, depending on any number of factors. Well, you could have lots of boilerplate code all over the place, but that's really boring. Instead, you look up a pattern called factory. In the factory pattern, you have a factory object, which, just like its real-world counterpart, is responsible for making objects. That's all it does, is make objects. So you have some kind of situation. Let's say you have a product you want to ship. And based on that product, you tell the factory, get me back the shipping object that's relevant. Maybe it's for Federal Express. Maybe it's for UPS. Maybe it's for USPS. Doesn't matter. As long as these conform to the same interface, you don't actually care which one it is. All the logic to decide which one it's supposed to be is encapsulated in the factory. So you ask the factory, get me whatever the appropriate object is. And the factory then says, all right, this product is going to this place. It's this kind of size. That means I need this object. And not only does it select the object, but it takes care of setting it up, creating its dependencies, all of that kind of fun stuff, and gets you back an object you can use. And then you can gleefully carry on doing whatever it is you're going to do with that object, not having to worry about how it got built because you don't have to think about it. That's the factory pattern. Similar to that, let's say you have an object where most of the algorithm is fairly consistent, but a few pieces are going to vary based on what shipping system you're using or user configuration or any number of things. How do you have an algorithm where you change only part of it at runtime? Well, you could try and invent something yourself, or you could look up a common technique called a strategy pattern. In strategy, you have an object that is incomplete, and it has some methods in it. And they're going to do what they do. But part of that algorithm will call to some object it doesn't have. Instead, it's another object called a strategy object that gets passed in when you're creating the object. Now this becomes part of the algorithm in this object. To anyone else, it's still a single object. This object here, your code, doesn't care that this object had pieces of it swapped out, and that's fine. You don't care. You just care that you can call A, and then, okay, A calls B, and B calls some object in the strategy object. That's fine. You can now vary your object at runtime, vary your strategy at runtime, vary your algorithm at runtime very, very easily. As in cooking, design patterns are not a rigid rule. Just because a given cookie recipe calls for exactly this much sugar and exactly this much butter doesn't mean it has to be done that way. You can vary it. Suppose some of your friends are vegan. Okay, so instead of butter, you use margarine. Instead of eggs, you use some kind of egg substitute. It'll taste a little bit different, but it's now a vegan cookie. Cool, your friends will love you, especially your vegan friends. A good chef knows how to vary his recipe based on the situation, put a personal spin on things, while still following tried and true patterns. Similarly in software, just because a command pattern normally has an undo command doesn't mean you have to have it. If in your case, you know you're never going to need it, or you know it isn't actually possible, okay, you leave it out. That's fine. The pattern is a way to help you skip over the process of inventing from scratch. Because really, you don't want to do that. Save your energy not for dessert, but for the main meal. Save your energy not for figuring out how to create objects. That's a solved problem. Spend your time on figuring out your actual business case. Another advantage of design patterns is communication. Suppose you tell your friends, come on over, I'm making butter combined with a little bit of baking soda and some vanilla with some sugar in it and some flecks of chocolate, which I'm then going to bake. They're going to stare at you and wonder what you're on. Because really, who's going to say that? Or you could say, come on over, I'm making chocolate chip cookies. And then your friends will come over because they understand chocolate chip cookies. Similarly, if you're talking to a colleague and you say, I'm going to create an intermediary object which I'll pass to you, and you will then access your construction objects through that object based on information in your contextually relevant situation, they will stare at you and their eyes will glaze over. If instead you say, I'm going to make a factory object available to you and here's the method you call, they can understand that. And you've now explained to them in very few words everything you've just done and everything they need to do. And they can also push back and say, all right, but the algorithm is pretty much the same. Aren't you going to need a strategy for that factory? Maybe. And you can have that conversation. And you can have that conversation at a higher level using terminology that you share. Even if you've never worked together before, using these terms, if you say a command object or a factory to someone, they understand what you mean. Just like when you say cookie to someone or stew, they understand in general what you mean. So take your time, work on the really hard problems. And for the common problems, the solved problems, follow the recipes, follow a design pattern. Use the terminology when talking to others. Save yourself the time and save your creative energy for making the entree, for making the actual business problem. And save time, go home and eat a cookie.